Second method of controlling the speed of DC motor is armature control method, or this is also called as rheostatic control method. The circuit arrangement of this control method is as shown in the figure. Here the rheostat, the variable resistor, is introduced in series with the armature winding, and by varying the resistance of this rheostat or the variable resistor, that either increase or decrease the armature current flowing through the armature, and as you change the armature current, that changes the drop taking place across armature resistance. So if you increase the resistance, that decreases the armature current, and that decreases the drop taking place across armature resistance, and that increases the speed, and vice versa. So it is graphically represented as armature current increases, the speed goes on decreasing. For no resistance in armature and external resistance in armature, two graphs are shown over here, and the gap in between these two graphs is the trough in voltage across the rheostat. So these are the equations concerned with the variable speed because of change in armature resistance and because of change in armature current. So from above relationship, for a given value of RT, the speed is linear function of armature current. So here at 0 armature current, this is no load speed, and for maximum armature current, that is called as stalling current. So wherein the speed reduces to 0. Now what are the disadvantages of this stalling current? Is this the maximum current at which the speed becomes 0, that is called as stalling current. What are the disadvantages of this method? This method is wasteful, expensive, and unsuitable for rapidly changing loads, because for a given value of RT, speed will change with load. More stable operation can be obtained by using diverter across armature in addition to armature control resistance, as shown in the following figure. So next method of controlling the speed of DC motor is voltage control method. So multiple voltage control and Ward-Lenor method. So in this multiple voltage control, multiple DC voltages are present over here, and these multiple voltages with the selector or the selector pointer, the different voltages are connected to the armature, and fixed voltage is given to the field winding, and that varies the voltage provided to the armature, and correspondingly the speed changes. Now the next DC motor is the DC series motor. The schematic of DC series motor is as shown in the figure, wherein the field winding and armature winding, they are in series. So this type of motor is called as DC series motor. In field control method, the current flowing through the field winding is varied by connecting a diverter across field winding. So when the resistance connected across field winding is changed, so the current flowing through the diverter changes, and as the total current entering into the DC series motor is fixed, the corresponding field current changes. So in this fashion, as IF changes, the field current, the flux produced by the field winding changes, and correspondingly speed changes. If the diverter resistance is large, then field current will be less, because more current will be diverted diverter resistance is small, the diverter current will be more, field current will be less. So flux produced by the field winding will be less, and corresponding field speed will be more. Secondly, armature diverter. In the same fashion, you can control the speed of series motor by connecting diverter, armature diverter. That is, the diverter is connected across the armature winding, by which you can vary the current flowing through the armature. So if diverter resistance is less, then diverter resistance current will be more. So field current is more, flux will be more, and flux will be more means speed will be less. So in this fashion, one can control the speed by by connecting the different types of diverters, that is across field winding and armature winding, and by varying the resistance one can change the speed of DC series motor. Next method is tapped field control. In this, the series field is tapped at different points, by which the field windings are changed, and those field windings changes the flux produced by the field winding, and correspondingly that controls the speed of DC series motor. Paralleling field. So if you connect different fields in parallel, field windings in parallel or series, that combination changes the flux produced by the field winding, and that changes the speed of DC series motor. Second method of controlling the speed of DC series motor is variable resistance in series with motor. So in this case, a variable resistor is connected in series with the motor, that changes the field current as well as armature current. So as that current flowing to the series motor changes, the field changes, and that is shown with the help of this graph. As current increases, the speed decreases. Introduced into the DC motor, there are two types of braking methods. One is regenerative braking method, and second one is dynamic braking method. Braking is very important in this any type of motor, of course, because by which we can stop the DC motor and we can achieve the desired results at the output. As you know, because of moment of inertia, the motors continues to rotate even if the supply is removed from the motor. So there is a need of stopping the motor at desired speed, because some applications are based upon the position controls. Instead of rotation controls, position controls. The motor should stop at a particular position. Like in armies, we need a position of guns at a particular angle. There we need to stop the motor at a particular position. So brakings are very important in such applications. So as I told, there are two types of brakings. One is regenerative braking and second one is dynamic braking. In regenerative braking, in dynamic braking, the braking